This is SpaceTime Series 27, Episode 110, for broadcast on the 11th of September 2024. Coming up on SpaceTime, the gigantic asteroid impact which shifted Ganymede's axis, a new way to measure the spin of a supermassive black hole, and NASA's solar sail mission tumbling in orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that the solar system's largest moon, the Jovian giant moon Ganymede, was hit by a massive asteroid 4 billion years ago, shifting its axis. The findings, published in the journal Scientific Reports, describe the event as one of the biggest asteroid impacts with clear traces in the solar system. The collision involved an asteroid roughly 20 times larger than the KT Boundary Vein asteroid impact, which 66 million years ago triggered Earth's fifth mass extinction event, wiping out 75% of all life on the planet, including all the non-avian dinosaurs. Ganymede is larger than the planet Mercury and has a liquid water ocean beneath its icy crust. Like the Earth's moon, it's gravitationally tidally locked, meaning it always shows its same face to the planet it's orbiting, and thus it also has a far side. Now, on large parts of its surface, the moon's covered by furrows that form concentric circles around one specific spot. And that led researchers back in the 1980s to conclude that that must have been the result of a major impact event. The study's lead author, Hirata Nayuk from Kobe University, says the Jovian moons Io, Europa, Ganymede and Callisto all have interesting individual characteristics. But what caught his attention was those furrows on Ganymede. Nayuk says astronomers know that this feature was created by an asteroid impact roughly 4 billion years ago. But they're unsure of exactly how big the impact was and what effect it left on the moon. See, data from this remote object is scarce, making research very difficult. But Nayuk realised that the location of the impact almost precisely on the meridian furthest away from Jupiter. He says this discovery has similarities to an ancient impact event on Pluto, evidence which was detected by NASA's New Horizons spacecraft. That event caused the dwarf planet's rotational axis to shift. And according to Nayuk, it implies that Ganymede too had undergone such a reorientation. Nayuk was then able to calculate the kind of impact that would have caused Ganymede's reorientation to happen. He found that an asteroid roughly 300 kilometers across, that's about 20 times the size of the one which hit the Earth 65 million years ago, would have created a transient crater between 1,400 and 1,600 kilometers in diameter. Transient craters are widely used in lab and computational simulations. They're actually cavities produced directly after a crater excavation and before material settles in and around the crater. According to the author's simulations, only an impact of this size would have made it likely that the change in the distribution of mass could cause the moon's rotational axis to shift to its current position. This giant impact must have had quite a significant effect on the early evolution of Ganymede. But the thermal and structural effects of the impact on the interior of the giant moon haven't yet been investigated. Ganymede's the final destination of ESA's JUICE spacecraft mission. If everything goes well, the probe will enter orbit around the moon in 2034 and will make observations for at least 6 months, sending back a wealth of data that could help answer Nayuk's questions. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, a new way to measure the spin of a supermassive black hole, and NASA's solar sail mission tumbling through space. All that and more still to come on SpaceTime. Astronomers have found a new way to measure how fast a black hole's spinning by using the wobbly aftermath of its stellar feasting. This new method, reported in the journal Nature, takes advantage of a black hole tidal disruption event. A tidal disruption event happens when a star gets too close to a black hole, and the black hole's powerful gravitational influence literally rips the star apart, shredding it into pieces, in the process releasing huge amounts of energy. As the star is ripped apart by the black hole's immense gravitational tidal forces, half of the star is usually blown away into deep space. The other half is flung around the black hole, forming an intensely hot accretion disk of rotating stellar material. As this material revolves around the black hole, it's being crushed and torn apart at the subatomic level, in the process releasing vast amounts of energy in X-rays. The study's authors have shown that the wobble of this newly created accretion disk is key to working out the central black hole's inherent spin. The astronomers measured the spin of a nearby supermassive black hole by tracking the pattern of X-ray flashes that the black hole was producing immediately following a tidal disruption event. The team followed the flashes over several months and determined that they were likely the signal of a bright hot accretion disk that wobbled back and forth as it was being pushed and pulled by the black hole's own spin. By tracking how the disk's wobble changed over time, the authors could work out how much the disk was being affected by the black hole's spin and, in turn, how fast the black hole itself was spinning. Their analysis showed that the black hole was actually spinning at less than 25% of the speed of light. The study's lead author, Diraj Prasham from the Massachusetts Institute of Technology, MIT, says the new method could be used to gauge the spins of hundreds of black holes in the local universe. If scientists can survey the spins of numerous black holes nearby, they can start to understand how these gravitational giants evolved over the history of the universe. They could also estimate the overall distribution of black hole spins and understand the long-standing question of how they evolve over time. Every black hole has an inherent spin that's been shaped by its cosmic encounters over time. For instance, if a black hole had grown through mostly accretion, brief instances of when some material falls onto the disk would have caused the black hole to spin up to quite high speeds. Now, by contrast, if a black hole grows mostly through merging with other black holes, each merger would slow things down as one black hole's spin meets up and against the spin of the other. Now, because of their intense mass and gravity, as a black hole spins, it quite literally drags the surrounding fabric of space-time around with it. Now, this frame-dragging effect is an example of lens-thirring precession, a long-standing theory that describes the ways in which extremely strong gravitational fields, such as those generated by a black hole, can pull the surrounding fabric of space-time with it. Now, normally this effect wouldn't be obvious around a black hole because these objects normally don't emit any light. That's why they're called black holes. But in recent years, physicists have proposed that in instances such as during a tidal disruption event, scientists might have a chance to track the light from stellar debris as it's being dragged around. And using that, they might be able to measure the black hole's spin. The idea is that during a tidal disruption event, a star could fall onto a black hole from any direction, generating a disk of white-hot shredded material that will be tilted or misaligned with respect to the black hole's spin axis. Basham says, imagine the accretion disk is a tilted donut that's been spinning around the donut hole, and that donut hole has its own separate spin. As the disk encounters the black hole's spin, it wobbles as the black hole pulls it into alignment. Now, eventually, the wobbling will subside as the accretion disk settles into the black hole's spin. Scientists predicted that a tidal disruption event's wobbling disk should therefore be a measurable signature of the black hole's spin. But the key to all this was to have the right observations. You see, the only way you can do all this is that as soon as a tidal disruption event goes off, you need to get your telescope looking at the object continuously for really long periods of time so that you can probe all kinds of timescales ranging from minutes to months. For the past 5 years, Basham and colleagues looked for tidal disruption events that were bright enough and near enough to quickly follow up and track for signs of lens-thirring precession. Then in February 2020, they got lucky. The Zwicky Transient Facility detected AT2020 OCN, a bright flash emanating from a galaxy about 1 billion light-years away that was instantly spotted in the telescope's optical band. Now, from this optical data, the flash appeared to be the very first moments following a tidal disruption event. Being both bright and relatively close by, at least in cosmological terms, Basham suspected that this particular tidal disruption event might be the ideal candidate to look for signs of disk wobbling, and possibly even measure the spin of the black hole in the host galaxy's core. Of course, the key was catching this really early on, because this precessional wobble would only be present early on. Any later and the disk wouldn't be wobbling anymore. Now, luckily, the authors discovered that NASA's NICA telescope was able to catch the tidal disruption event and continuously kept an eye on it over the following months. NICA, the Neutron Star Interior Composition Explorer, is an X-ray telescope mounted on the International Space Station. It's used to measure X-ray radiation around black holes and other extreme gravitational objects. Pisham and colleagues then looked through NICE's observations of AT 2020 OCN over 200 days, following the initial detection of the tidal disruption event. They discovered that this event emitted X-rays that appeared to peak every 15 days for several cycles before eventually petering out. Now, they're interpreting these peaks as times when the tidal disruption event's accretion disk was wobbling face-on, emitting X-rays directly towards NICE's telescope, before wobbling away as it continued to emit X-rays. It's sort of similar to waving a flashlight towards and away from somebody every 15 days. The authors then took this pattern of wobbling and worked it into their original theory for lens-stirring precession. Based on estimates of the black hole's mass and that of the disrupted star, they were able to come up with an estimate for the black hole's spin, less than 25% the speed of light. These results mark the first time that scientists have used observations of a wobbling disk following a tidal disruption event to estimate the spin of a supermassive black hole. More on this report from the Massachusetts Institute of Technology.
When a star passes too close to a massive black hole, it can get shredded by tidal forces. In the process, a new misaligned accretion disk forms around the spinning black hole that is hot and emits mainly X-rays. Due to strong gravitational effects, this misaligned disk precesses, and this manifests as quasi-periodic brightness changes in the X-ray band. Over time, the accretion disk will come into alignment, and the changes in brightness of the X-rays will diminish. Astronomers, led by Dheeraj Pasham, have observed one such event that repeats every 15 days. Assuming these modulations are due to a general relativity-induced effect called lens-stirring precession, they estimate that the black hole is spinning and dragging the space-time around it at a rate of less than 25% the speed of light.
This is SpaceTime. Still to come, NASA's solar sail mission tumbling in orbit, and later in the Science Report, Semaglutide found to reduce the risks of heart failure and dying from any cause, including COVID-19. All that and more still to come on SpaceTime. NASA says its Advanced Composite Solar Sail System spacecraft is currently tumbling or wobbling through space, which may have impacted its orbit. The mission successfully erected its foiled solar sail in orbit last week after a failed attempt a few days earlier. However, observations show the spacecraft is now tumbling or wobbling in orbit. The mission was designed to test a new type of solar sail, one that could eventually propel spacecraft using photon pressure from the sun. This technology could one day transport spacecraft to the edge of the solar system and beyond faster and cheaper than existing chemical rocket engines. This latest test, known as ACS-3, was launched aboard a Rocket Lab Electron rocket from New Zealand's Mahia Peninsula on April the 23rd. The satellite was placed in a 965-kilometre high low Earth orbit. The mission uses a sail that's folded up stored aboard a microwave oven-sized CubeSat spacecraft. The solar sail's deployed using a series of folding composite booms that are 75% lighter and more resistant to solar radiation than those used on previous solar sail missions. First attempts to unfurl the 80 square metre silver foil solar sail back on August the 26th were abandoned after 25 minutes because onboard power monitors detected higher than expected motor currents. After reviewing the issue, a second, more successful attempt was made last week. Images of the spacecraft from the ground confirmed the sail had properly deployed. However, they also showed that the spacecraft was dramatically brightening and dimming at regular intervals, suggesting that it was slowly tumbling or wobbling through space. And its orbit has also shifted unexpectedly. Now, right now, mission managers are claiming the tumbling wasn't unexpected, and it's simply part of the planned sail deployment sequence, which they say should be corrected in coming weeks. Needless to say, we'll keep an eye on it. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that semaglutide, a diabetes drug that's now become best known for its weight loss properties, can reduce the risk of heart failure events and cardiovascular death in people with diabetes and chronic kidney disease. The findings, reported in the Journal of the American College of Cardiology, is based on an analysis of data from previous clinical research called the FLOW trial, finding that semaglutide could reduce the risk of heart failure by 27% and reduce the risk of death by any cause by 29%. A second study in the same journal found that semaglutide can also help improve the changes to heart structure associated with obesity, which can often lead to heart failure. The authors say this points to how the drug might be working to benefit people with obesity-related heart failure. Meanwhile, another study in the same journal, also looking at semaglutide, found that people who are overweight or obese have a reduced risk of dying from any cause by taking the drug, including COVID-19, compared to those not taking weight loss medications. The authors were looking at death data from semaglutide trials involving some 17,500 participants over the age of 45 who were either overweight or obese. Half were randomized to receive semaglutide weekly, while the other half took a placebo. Over an average follow-up of just over 3 years, researchers found that 833 patients died. But participants taking semaglutide had a far lower risk of death from any cause, as well as from heart-related deaths. The most common non-heart-related cause of death was from an infection, and researchers say these also occurred at a lower rate in the semaglutide group. Participants taking semaglutide were just as likely to be infected with COVID-19 as other patients, but they were less likely to have serious complications or die as a result of the virus. A new study claims current screen time before sleep recommendations for kids are neither achievable nor appropriate. A report in the Journal of the American Medical Association claims the findings are based on camera observations of kids over 4 consecutive nights, measuring screen time before bed of 79 11 to 14-year-olds. They found that screen time in the 2 hours before bed had no association with most measures of sleep health. However, screen time once in bed, especially interactive activities such as playing games or multitasking, was associated with less sleep. The results indicate that current recommendations of absolutely no screen time in the 2 hours before sleep might be a bit much for kids, and sleep effects may be more dependent on the type of screen time instead. Apple's new iPhone 16's just been released with new design changes, a new AI processor, and upgraded cameras. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Okay, so the new iPhone 16s have been launched. You can go to apple.com and watch the live keynote. You can go to youtube.com/Apple and watch it there. I highly recommend you do that. There's lots of AI. Now, the problem with the AI is that a lot of the AI features won't come until 2025. That includes Siri version 2.0, where you can talk to Siri like you're talking with ChatGPT. This is in stark contrast to Google, whose new Pixel 9 Pro and the Pro Fold already have Gemini Live and can do all the AI stuff out of the box straight away. And in fact, I've been playing with the new Pixel 9 Pro Fold, and it's glorious. It's normal-sized phone when it's folded shut, but when it's opened up, it's this beautiful thin device. And Apple is not scheduled to launch one of those until potentially 2026 or beyond, but they will want to have a screen that has no crease. And Apple has also launched its new Apple Watch 10, the 10th series, thinner, and also the Apple Watch Ultra 3.
Now, have you done the Alexa test yet?
I haven't, but I've seen a number of videos where you ask Alexa about President Trump and it says, oh, sorry, I can't get political. And then you ask it about Kamala Harris and you get all this information about how she's a great person. And already Alexa has apologized and said, it was an error. But it's a funny thing how these...
That's the only reason they're apologizing.
Well, the thing is, it's always funny how these errors always seems to go against Trump or against conservatives and for the Democrats. So it's, yet another case. I mean, Grok came out straight away and was able to explain who both candidates were without any problems. And there was another test I saw online where one of the posters on X was giving a description of basically a democratic socialist / communist type of government. And initially ChatGPT was, according to this poster, giving all sorts of weird answers. But Grok straight away said, well, this is basically a communist type of government. So other people came along and they asked ChatGPT and it seemed to be giving, more intelligent answers. But we're definitely living in this strange time where the AI is being programmed by somebody else, and you can't go in yourself yet and determine whether you want your AI to have a totally neutral bent or for it to look at...
Why doesn't Jeff Bezos simply sack these idiots who are doing this programming? Because it reflects badly on his company.
Well, it does, but he's now basically retired. He's doing other things. He's Blue Origin. I mean, he's not involved in the day-to-day at Amazon anymore. No, he's not going in here either, but he does have a CEO, and the CEO is looking after these things. But the problem is that sometimes the CEOs might be of one political flavor, and yet the people working for them are of the other. And that's what happened at Twitter. I mean, Elon Musk was able to sack 80% of the staff, and X is running better than ever. In fact, they just launched the X app for your TV. If you have a smart TV, you can now download X, and this is going to be changing X into more of a video platform. Just like YouTube is this fantastic repository of all this incredible knowledge, so too will X become that sort of a platform too. I mean, you can do it now, but now with the X app, you can fire it up on your TV, use your remote control, and be watching many of the things. There are so many different live events, and people's channels are now on X. I'm actually going to be doing more X videos myself, as well as publishing it to YouTube and Rumble. But there's lots of movement happening, and we still haven't seen Grok version 3. Now, Elon Musk just announced Colossus, which is 100,000 H100 NVIDIA chips. It was completed in 122 days, and it will be training Grok version 3. Grok 2, the beta version, and the beta Grok 2 Mini has now been launched. If you've got X and you pay for the premium, you can play with it. But the whole impact of AI, 2025 is going to see massive changes in how we use our computers and technology and interact with AI on pretty much every platform.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.